First chapter on statistics, and you've got some blanks to fill in, and I get to click on them. Oh, science of data. Sounds exciting already. So we get to look at data, analyze data, figure things out, abuse that data, right? Lots of people use statistics to lie about all sorts of things. So how do we figure out how that works? And we're going to look at univariate analysis. This is just combining a couple of words together. Uni means one. Variate has to do with variable. Oh, it includes one variable. Surprise, surprise. Okay? We look at shoe sizes. We're only looking at one thing. We're also going to look at bivariate data later when you're comparing things. Right? Some things compare. Some things don't. Oh, you've got gray shoes. Must be smart. Probably not. It's not like, oh no, I'm going to fail my math test today because I wore red shoes. Therefore, I won't be able to do math. That would be disastrous. It'd be really weird if that actually helped. I'm going to check, first stats test, how many people are wearing gray shoes. See if it makes a difference. Okay? Then you're just getting superstitious. But some things do compare, right? There are like how far you can reach and how tall you are. They're really, really close together, right? Some people have extra long arms and are short. Then we say they're disproportionate because they look, they look funny. No, I'm not looking at anyone in particular at this moment. But we have these ideas of things that should fit together, and for most people they do, and for some people they don't, and then all of a sudden it's like, oh. Okay? Our data that we gather, sometimes data is gathered that's qualitative, descriptive, and sometimes it's measured with a value. We're going to be looking, since this is a numbers class, mainly with the stuff that can be measured, right? We're not going to be looking at that stuff that is descriptive as much. Quantitative data is either continuous or discrete, okay? Discrete is like shoe sizes. You can't go to a store and say, last night I measured, my feet grew a millimeter, so I would now like to buy 8 1/16 size of shoe, please. No, sorry, we have 8 and we have 8.5. We don't have 8 1/16 size. But other things are continuous. Your height. I always imagine, what would it be like if, when you measure your height, you always tell someone, oh, I'm 5'5" or 5'6". No one says, oh, I'm 5.47382916. You don't say all the decimals. You say it in those amounts that's rounding, but you don't actually grow that way. It's not like you're sitting at 5'5" and all of a sudden you start to shake, and then a minute later, boom, you pop up an inch. Because when you grow, it's continuous. You are hitting all the values in between until you get to 5'6" when you say you're 5'6". But I imagine, what would it be like if we grew discretely? All of a sudden, it'd be like in the middle of class, boom, someone grew an inch. And they'd just sort of like pop in their desk. Could even like make a loud noise. It would be really quite exciting. Except, when is like the biggest growth spurts? Is it like grade 9, grade 10? What do you think? It depends on the person, but overall in general, like would it be?
It's different for boys and girls too. Girls grow earlier.
Girls earlier, so your grade 7 class of girls, all the girls are going pop, 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 like popcorn. And then you wait to grade 9, and the boy, So that's what the difference between continuous and discrete, okay? So the height of students would be continuous, but the number of students that have smartphones or the number of students in my class, that would definitely be discrete. It's not like we're having another student enter our class, and then over the day, this student slowly starts to appear until they're completely there. No. So that's the difference between continuous and discrete. We talk about population being everything that we're studying in a certain statistical study that we're collecting data from. So if I wanted to know what Canadians think or what is the average height of Canadians, my population is everybody in Canada. Usually, though, it would take a long time to ask every single person. But people are still interested in finding out, what does the average Canadian think, or how tall is the average Canadian, or what is the life expectancy of the average Canadian? And they have data on that. They don't ask every single person, when did you die? Okay, that's not a good example. Yeah, so life expectancy isn't really a good one for surveys, but you can't ask everybody, so instead you get a sample, and you use that sample to tell you stuff about the population. And this is where statistics gets interesting, because you want your sample to tell you what you think the real population is doing. So we talk about taking a random sample. And if you take a random sample, then there's a better chance, right, of it representing the whole population. Okay? But sometimes the size of the sample also can be a bias. Okay? Now I'm going to ask, I want to know, when is the average person's birthday in this class? Okay? So if I take a really small sample, Julia, when's your birthday? January 15th. And then I say, everybody in this class has a birthday on January 15th. Well, my sample was a little small. And even though it was random, I could have picked anyone, it doesn't really represent the whole population. So not only do we have to take a sample that's random, but you need to make sure you have enough of the sample to be a good representation. And so part of statistics is looking at those kind of things. So we start off by trying to organize and present our data. And one of the ways that's nice to present our data is through a frequency table. And that frequency table can help us understand it better. We can also represent it as graphs. So here's our first example with a bunch of data. Scientists counted how many fish were caught in a net every day for 30 days. And there are the results. The results, the way that they're listed right now, doesn't really tell us very much. I mean, it tells us a lot if we wanted to really look at it, but it's not organized very well. So what does a frequency table look like? Well, if we look at the number 10 and we count it each through the days, and I'm not going to get you to fill this out and count it all on your own because it could take a while. I have all the answers here. It's like, oh, there's 3 times that 10 happens. And so on. You can fill out and count them as you go. Would that be hard to do? No. Would it be a little time consuming? Maybe. One of the things that I don't like about statistics is the time it takes to do not very interesting math. I don't mind doing, you'll find this out, you can probably sense it. I don't mind spending time doing math, but I would like to do interesting math. Counting tens. There's 3 of them. Fortunately for me, that doesn't fall into like, ooh. I'm like, oh, that was so much fun. I'm going to count the tens again just to make sure. No, it's not necessarily the most exciting math. But now that we've tallied these things, we get A better picture. Oh, they just started a dentistry class. We get a better picture of the stuff that's going on. And then if we take that and put it into a bar chart, it tells us the information in another way. Frequency, number of days, because that frequency, it happened 3 times, it happened 4 times, how many days, and then the number of fish caught along the bottom. So we have the same data in 3 different ways. And I think that the visual bar graph in the end can tell me a lot more stuff quicker than just the set of numbers at the beginning. I'm like, oh, they most often caught 18. I can see that right away. I can also see that right away in my frequency chart. I can't see that right away just in my list of data. Now what we're going to do next is play a little bit around with our calculator. Okay? First of all, with our calculator, we're going to just put in all of these numbers. So if you have your calculator, you can take it out. If you don't have your calculator, I have a couple extra here that work. Looks like I've got 4. So if you want to just come and borrow a calculator, you can come pick one up. 1, 2, 3, 4, 5. I think I might have another one. Yeah, you get the crappy one. And does this one look like batteries are maybe dead? You get the big one. Their batteries are dead. Here are some batteries. To take out the batteries, that button on the side, this pops out and you take them out. Yeah. Oh, here's that. Okay, so what we're going to do is we're just going to put in all of the numbers into our calculator under stat. So hit the stat button and then hit edit. If you have data in there already, it's important to know how to clear the data, and it's not necessarily intuitive. If you hit delete, you could just get rid of list 1 altogether, which we don't want. So let's say you have some data in here that you don't want, like 5, 8, and 2. To get rid of the 5, 8, and 2, you can go up to list 1, don't hit delete, but hit clear, and then push down. If you hit delete, it makes the whole thing go away, but then list 1 is gone. There's ways to get list 1 back, but it's better not to make it go away completely. Okay. So now that we have it, we can enter in the numbers that we see here. 10, 12, 15, 10, 12, 15, 10, 18. Oh, and this is tedious, right? This is, I'm supposed to should have picked a month with less than 30 days. I guess February wouldn't be that much better. Okay, one of the things that can be frustrating in statistics is if you type in something wrong, you will get the wrong answer. I'm not very confident right now that I've typed in everything correct or haven't screwed up along the way. But we're going to find out by checking with you as well. Looks like I thought there was 30 days. Why do I have 31? Oh. Okay. So there's my first check that I screwed up. Yes, I did. Inputting the numbers in. I'm going to go back to the beginning and double check them. Whoa. Oh. There we go. 10, 12, 15. I'm going to look on my computer. It's going to be better. 10, 12, 15, 10, 18, 17, 11, 17, 10, 12, 18. 13, 18, 17, 12, 18, 11, 18, 17. Oh, there it is. 17, 16, 13, 14, 15, 17, 18. Perfect. Okay, so I accidentally added one number in there twice. How hard was that to do, to make a mistake? Very easy. So sometimes statistics can be frustrating just because you enter a number in wrong. Getting the batteries out is tricky. Okay, now what we have on our next page of our notes is some instructions. Once you have data in your calculator, our calculator can calculate a bunch of things for us easily. Some of them that we're going to look at right now are median. We're going to talk a little bit about quartile 1 and quartile 3 right now, even though we don't know what that is, and standard deviation, maximum and minimum values. So we go back to our calculator. We hit our stat button, and we go over to calculate. And under calculate number 1, we can just push enter. One var stats. It says which list, what's our frequency list, calculate. We put everything into list 1, so that should stay the same. We don't have a frequency. We're going to look at that next as the next thing that we're going to do. And then go to calculate and push enter. It tells you a bunch of things. The X with the bar over top, that's your mean. That's your arithmetic average. That would mean you added them all up and divided by 30. This is where the calculator is nice. Quickly in your head, add them all up and divide by 30. Not quick, right? But your calculator does that all. The average is 14.4. Okay? It has some other stuff. Do you know what that Greek letter sigma means in math? It means a sum. So it's a symbol that we need to know for this year. The calculator decided, hey, if you were curious and you wanted to add them all up, it's 433. All the numbers we put in added up to 433. Then it's got sigma x squared. If you were curious and you wanted to square all the numbers and then add them up, well, it's 6,489. I know that that's been, like, I'm sure as soon as you saw that list of numbers, you were probably like, oh, I wonder what would it equal if I squared them all and added them up, right? How many people, is that the first thing that came to their mind when they saw those numbers? Obvious, I know. Okay? But we have some other things. We've got some standard deviations, which we're going to learn what does that 2.82 mean later on. It tells us the minimum number is 10. If we scroll down by hitting our arrow key, it tells us the median is 14.5. Do you know what a median is? Do you remember that from grade 9 statistics? The median is the number that happens right in the middle. Okay? So if you had 5 pieces of data, the median is the third one, the one right in the middle. Okay? It's a different way of saying the average. Every time you want to know, oh, how did people do on that assignment, often people ask what the class average was, And that's the arithmetic mean. But sometimes people want to know, what was the median? So if I did a quiz and I said the median was 70%, that means half of you got higher than 70%, half of you got less than 70%. It's where half the class is and half the class is. Okay? What does it mean if the class average was 50%, but the median was 70%? Some people got really, really low in order to drive that, because half the class got over 70, but the average in the class was 50. Okay? So sometimes those different averages, and we're going to do some work with that, can be helpful. Okay? Quartile 1 and quartile 3, those are like first quarter and third quarter. If the median is 50% got higher and lower, quartile 1 is the 25% mark. 25% got lower, 75% got higher. Quartile 3 is the 75% mark. 25% got higher than that, 75% got lower than that. Okay? And then, of course, there's a maximum value as well. So we put in our data all loose like that, but if we had looked back at our frequency chart from before, another thing we can do, so now I'm going to go back to our calculator. We're going to go to our mode, go back to stat, go back to edit. And all that data we put in, we're going to move up and push clear and down to make it disappear. Now for our data that was put in, this is actually going to be easier to put in as a frequency chart, because we know that our numbers go from 10 to 18, so that actually allows us to enter the numbers in quicker, unless we screw up like we just did there. 13 after 12, good. And put our frequencies in right next to it. 3, 3, 4, 3. 3, 3, 4, 3, 2, 2, 2. I found that that was a lot quicker to type in than just the random data in without any order. So having made my frequency table first, it allowed me to put my data in quicker. Okay? Now, when we go to stat and calculate, notice on my calculator, and depending on your version of calculator, how many people's calculator doesn't come up with this option, okay? Then it just says 1 var stats across the top, right? So a couple things. A, you could upgrade your calculator to a newer operating system. It's not hard to do. We can do, and then you get more information showing. Or I can show you what needs to show up when you're typing it on yours. Okay? With the first one, you could just push enter when it showed up and it worked for you, right? For the second one, our list comes from list 1. Our frequency comes from list 2. List 2 is right above, so you have to go second, list 2. And now when we go to calculate, it figures out everything exactly the same. I'm sure you memorized that number. 6,489 was the sum of all the squares. It's still the same. Okay, same average at 14.33, same median value. All of the values are the same. So on that calculator there, Spencer, you would have to go list 1 comma list 2 after, and that would do the same thing. This is how you would. This is how it would show up on your calculator. 1 var stats, and then you go list 1 comma list 2 and push enter. Okay. Another thing that we're looking at, different than a bar graph, is something called a histogram. The difference from a bar graph is a histogram has no space in between your bars, and the width of each bar is equal to a class width of what you're looking at. Often, it doesn't make sense to look at individuals, but instead look at what a group of people is doing, right? How much do people spend at the movies? Well, I'm interested to find out kids between the ages of 10 and 15, 15 and 20, 20 and 25, 25 and 30, and so on, to find out who's spending the most money at the theaters. And then maybe if I'm a marketer, I'm like, ooh, this is what we should sell at the theaters. Because when those 10 to 15-year-olds are coming, maybe it's not a good idea to bring in the person who's operating the bar. Those kids should not be going to the bar to buy stuff. But maybe we should sell more candy during that time. Those kind of things. Here's how to create on our graphing calculator. We're going to look at that when we get to our second example. But this is what a histogram looks like. It's the ages of 200 people in a village. What it means is that here, between 0 and 20, between the ages of 0 and 20, there are 40 people in this village that have that age. The mid-interval value, in other words, the average of people between 10 and 20 are 10 years old. So we can fill in the rest from the chart. Okay? I'll give you a head start to fill it in. I'll put up the answers in a second. So use the chart to fill in the rest of the value. And check how you did. So we can use a histogram to give us some estimates. What is the average age of a person in this village, just given this histogram? Well, there are 40 people between the ages of 0 and 20. We don't know exactly what their ages are, but we could say on average, between 0 and 20, on average they're 10 years old. Between 20 and 40, their average age is 30. And so if we would say there are 40 10-year-olds, 70 30-year-olds, 100 50-year-olds, 50 70-year-olds, and 10 90-year-olds, we could use that to calculate the average age. How would that look as a big long equation? Well, our average would be 40 10-year-olds, that adds up to 400 years, 70 30-year-olds, get the total age of all of them, divide by 270 people, and we've got an average age at 44.1 years old. Couple things about my answer. Notice the approximation sign. Because we rounded that. How many numbers do we round to? 3 significant figures. So start working on the next one. We've got a frequency chart. Do a quick check on some of the things already. Number of hours of sleep is continuous because you don't sleep in like only 1 minute chunks or 1 hour chunks. It's not like if we don't wake them up now, they're going to sleep for another hour for sure. And were you able to follow the instructions with the graphing calculator to get that to show up on your screen? If you didn't have time right now, that's going to be one of the things I'm going to get you to do as homework. Try to get that histogram to appear on your calculator. Okay? We've got the midpoint value in each of those. The width of each of those bars goes from 1 to 3. So if you were drawing this by hand, which is more typical of what you might have to do on a test, you make your width from 1 to 3. Since there were, this says number of students because you can't read my writing. Since the number of students was 2, it goes up 2 high. From 3 to 5, there was 7 students. That bar goes up 7 high. So for the last question, to save you some time, how much fun would that be to count everything? So much fun. How many are between the ages of 25 and 30? Okay. I'll just give you that data so you don't have to count it. And then for next class, I'm going to ask you to draw that histogram as well as estimate using this frequency table to estimate the average age.